Today we are going to learn about mastering multi-sheet Excel imports with Pandas. We'll cover how to efficiently import data from multiple Excel sheets, ensuring data integrity and optimizing performance. Welcome to our session on mastering multi-sheet Excel imports with Pandas. In the world of data analysis, Excel remains an indispensable tool, especially when dealing with datasets spread across multiple sheets. However, extracting and consolidating this data can be challenging without the right tools. That's where Pandas, a powerful Python library, comes in. Throughout this video, we'll dive deep into the read_Excel function, a key feature for importing Excel data into Pandas efficiently. We'll explore how to leverage this function to handle multiple sheets, optimize performance, and maintain data integrity. Let's get started on this exciting journey. The read_Excel function is a cornerstone of importing Excel data into Pandas. This function allows you to read data from Excel files into a Pandas data frame, making it easier to manipulate and analyze. Let's start with its basic syntax, pd.read_Excel file.xlsx. This command reads the first sheet of the specified Excel file. One of its parameters is sheet_name, which lets you specify which sheet to import. For example, pd.read_Excel file.xlsx, sheet_name equals sheet 1, reads data from sheet 1. Understanding this function's parameters is crucial, as they allow for flexible data imports and cater to various data structures. Make sure to explore Pandas documentation for detailed insights on each parameter's functionality.
The sheet_name parameter is your gateway to multi-sheet imports. You can specify a sheet by its name or index. For instance, pd.read_Excel file.xlsx, sheet_name equals 0, reads the first sheet by index. To read multiple sheets simultaneously, use a list, pd.read_Excel file.xlsx, sheet_name equals sheet 1, sheet 2. When dealing with dynamic sheet names, consider using pd.read_Excel file.xlsx, sheet_name equals none, to import all sheets. This returns a dictionary of data frames, with keys as sheet names. Handling non-existent sheets is also vital. Using try-except blocks or checking sheet existence with XLRD or OpenPixel libraries can save you from runtime errors. Importing all sheets at once is a powerful feature when dealing with large Excel files. By using sheet_name equals none, you can load all sheets into a dictionary of data frames, where each key value pair represents a sheet. This method simplifies the handling of Excel files with numerous sheets, as you can iterate through the dictionary and process each data frame separately. For example, for sheet, data in pd.read_Excel file.xlsx, sheet_name equals none. Items, print sheet, data.head. This approach allows for targeted data manipulation and analysis, based on specific sheets requirements, fostering efficient data management. Once your data is imported, sheet-specific transformations might be necessary. Each data frame can undergo different operations based on its data. You can apply functions to data frames using methods like apply or assign. For instance, df.apply lambda x, x2, doubles numeric data. Merging data across sheets can be achieved using pd.merge or pd.concat, enabling comprehensive data views. Standardizing formats, such as dates or currencies, ensures consistency, while handling missing values with filna or dropna maintains data integrity. Tailoring transformations to each sheet's context is crucial for accurate data analysis and reporting. Working with large Excel files can strain system resources, but Pandas offers ways to optimize performance. Efficient memory usage is paramount. Consider reading data in chunks using the chunk size parameter, pd.read_Excel file.xlsx, sheet_name equals none, chunk size equals 1000. This loads data in manageable pieces, reducing memory load. Specifying data types with the dtype parameter can also decrease memory usage. pd.read_Excel file.xlsx, dtype equals column_name, int 32. Reducing data frame size through methods like drop or astype helps manage large datasets effectively. Utilize profiling tools like memory_profiler and pandas_profiling to identify and address performance bottlenecks.
Errors are inevitable when working with file imports, but understanding common issues and their solutions can streamline the process. Missing files or sheets can cause runtime errors. Ensure files exist and sheet names are correct. Corrupted sheets might require manual correction or using alternate reading methods like OpenPixel. Read errors often stem from incorrect file paths or unsupported file formats. Data type mismatches can be resolved by specifying dtypes or using converters. Employ try-except blocks to catch and handle errors gracefully, providing informative feedback or alternative actions. Anticipating and addressing these challenges enhances reliability and user experience.
Data consolidation is a powerful technique for aggregating information from multiple sheets into a unified dataset. By merging data from different sheets using pd.concat or pd.merge, you can create comprehensive views for analysis. For instance, consolidating sales data from regional sheets into a single dataset allows for global sales insights. Creating summary reports through data frame aggregation methods like Group B or pivot_table further enhances data understanding. Visualizing consolidated data with libraries like Matplotlib or Seaborn provides intuitive insights. These techniques are invaluable in scenarios like financial reporting, inventory management, and customer data analysis, offering a holistic view of organizational data.
Maintaining data integrity during imports is crucial for reliable data analysis. Ensuring data accuracy involves checking for discrepancies or errors post-import. Consistent data formats across sheets, achieved through standardization, prevent misinterpretations. Validating imported data against expected results or predefined criteria ensures accuracy. Automating data checks through scripts or tools like PyTest or Great Expectations can streamline validation processes. Thoroughly documenting import processes, including steps, parameters, and assumptions, aids in reproducibility and accountability. By prioritizing data integrity, you safeguard against errors that could compromise analysis and decision-making, ensuring trustworthy outcomes.
For seasoned data professionals, advanced techniques enhance multi-sheet imports efficiency and flexibility. Integrating pandas with libraries like OpenPixel expands functionality, allowing for Excel writing or more complex operations. Advanced indexing methods, such as multi-level indexing, enable intricate data manipulations across sheets. Handling dynamic sheet names through conditional logic or metadata files accommodates changing datasets. Creating customized import functions encapsulates repetitive tasks, streamlining workflows. Integrating pandas with visualization or machine learning libraries, like Plotly or scikit-learn, transforms imported data into actionable insights. These advanced techniques equip you to tackle complex data scenarios with agility and precision.
As we conclude, let's reflect on the skills we've developed today. From understanding the read_Excel function to advanced multi-sheet import techniques, Pandas offers a comprehensive suite of tools for Excel data imports. Mastering these techniques not only enhances your data manipulation capabilities but also empowers you to handle complex datasets with confidence. I encourage you to practice these skills, explore further learning resources, and apply them to real-world scenarios. Stay curious and keep honing your data skills. Thank you for joining us on this learning journey.